Good morning. So today's lesson is just about going through the practice questions from your assignment booklet. Now recall I've done this for 7.1, which was the slope y-intercept form of an equation. 7.2 was the general form of an equation, and today's lesson 7.3 is on the slope point form. Keep in mind that all three forms of an equation are interchangeable. You can go from one to the other, and they all simply are different ways of describing a linear relation. Each of them has pluses and minuses insofar as what they give you. Today's slope point form, remember, is y2 minus y1 equals the slope times x2 minus x1. Now remember, this is just a rearrangement of the slope formula. Okay? Remembering that the slope formula is simply slope equals y2 minus y1 over x2 minus x1. Okay? So we've just rearranged this formula. We've multiplied both sides by x2 minus x1 to get rid of it on this side and bring it over here. And so that gives you this formula. One advantage of the slope point formula is you can get it if you know the slope and any one point on the line. And it truly is any one point on the line. So in other words, the slope point formula is the only one where you can get two different formulas, right, with different values for y1 and for x1, and it will still describe the same line. And we'll take a look at a question a little bit later that shows how that works. Okay? To start with, though, we're just going to talk a little bit about rearranging, because you've got to, as I've said many times, you've got to be very good at rearranging between one form and another. Okay, so that's what we're going to start with. And our question is asking us to convert the equation y minus 5 equals negative 3/8 times x minus 12. So that's slope point form, right, where we have a value for the slope of negative 3/8. We have a value for y1 of 5 and a value for x1 of 12. Okay? And we're being asked to simply rearrange this into slope-intercept form, which, just to review, is y equals mx plus b. Okay? In this form, you can, just by looking, you can find the y-intercept and the slope. Okay? Whereas with this one, just by looking, you can find the slope, negative 3/8, and a point on the line that has an x value of 12 and a y value of 5. And again, notice that the signs on these numbers in the formula are the opposite of the signs on these numbers when you write it as an ordered pair. Okay? So, we know the slope, we know one point, we want to rearrange it into this form. And we have a fraction here that's going to cause us grief a little bit later, but for now, I want you to get used to going through the same series of steps to simplify an equation that's in slope point form. Okay? And so what you want to do is you want to simplify the right side and the left side as much as you can. So we're just going to write this out. Y minus 5 equals negative 3/8 times x minus 12. Okay? So you're going to want to simplify the right side. And we do that by distributing the number in front of the brackets by everything inside the brackets. We can't simplify the left side anymore. We can't combine these, they're not like terms. So we just write it over again. Y minus 5, negative 3/8 times x is negative 3/8 x minus negative 3/8 times 12. Remember, when you go negative times minus, that's more simply thought of as just being addition or plus. And that gives you 3 times 12 is 36 over 8. Okay? Now, at this point, you might want to get rid of these denominators, okay? Because we're going to be starting to isolate y, and it might be easier just to get rid of these denominators before we have to worry about adding and subtracting involving fractions, okay? So I would suggest at this point that you get rid of the denominators. And remember from previous lessons, to get rid of a denominator, you just multiply through by the least common denominator, which in this case is 8. So we're going to multiply 8 times y. That'll give us 8y. 8 times minus 5 will give us minus 40. 8 times minus 3 will give us minus 24 over 8x. And 8 times 36 will give us a very big number. 8 times 36 would be 288 over 8. Let's just see if Mr. Calculator can check my multiplication. I got it right. Okay, so now let's simplify these fractions. The reason we multiply through by the least common denominator, in this case 8, is to produce a fraction that will then simplify to give us a whole number. So negative 24 divided by 8 is negative 3x. 288 divided by 8, again, hello Mr. Calculator, is 36. Now we have an equation with no fractions in it, and we can go ahead and isolate y. So we're going to add 40 to both sides. I'm going to go up here and rewrite it. So the 40s will cancel on the left, and you'll end up with 8y equals negative 3x plus 76. Okay? And our last step is to isolate y. So we're going to divide every term. Remember, whenever you multiply or divide, it's always got to be every term. Okay? So 8 divided by 8 will leave us with 1y. This gives us negative 3/8x, which, remember, was our slope. So this is a way of checking. If you get to the end, check and see if you have the same slope that you had to begin with. Plus 76 over 8 would be 9 4/8, or more simply, 9.5, or even 9.5. Okay? So, what have we got here? We've got an equation in slope-intercept form that tells us that the slope is negative 3 over 8. We knew that. And it tells us what the y-intercept is. The y-intercept is 9.5 or 9.5. Okay? That took a long time, and sometimes rearranging does take a long time. So now we want to put this into general form. Okay? Now, we can either go with our equation that we've just isolated into y equals mx plus b, or we can go right back to our original equation and put that one in general form. It doesn't really matter which you choose. I'm just going to take this equation that I have, so just let me do some erasing here. Okay, so we've got our general form equation, our slope-intercept form equation. We want to convert it to general form. So y equals negative 3/8 x plus Now I'm going to put this back into an entire fraction. Okay, so 9 times 2 is 18, plus 1 is 19 over 2. Okay? We have to change this into general form. Well, what does that mean? Remember, that was lesson 7.2. In general form, they take the form ax plus by plus c equals 0, where a, b, and c are integers, and a has to be positive. Okay? So no fractions, no decimals, no negative on the number attached to the x. Okay? So, as we said before, the first step in putting something in general form is to move everything to one side. So we're going to subtract y from both sides. That will remove it from the left side, leaving us with 0, and leave us with negative 3/8 x minus y plus 19 over 2. Okay? Now we check to make sure that there are no fractions. Well, duh, there are fractions here. And we also check to make sure the number attached to x is negative. Again, duh, it's not. So, we have to get rid of the negative. We also have to get rid of the fractions. So, to get rid of the fractions, we multiply through by the least common denominator of 8 and 2, which is 8. To get rid of the negative sign, we simply make that a negative 8. Okay? And then we multiply every term, yes, even the 0, by negative 8. So negative 8 times 0 is 0. Negative 8 times negative 3 is positive 24 over 8x. Negative 8 times minus y is plus 8y. Remember, negative times negative will give us a positive answer. And negative 8 times positive 19 will give us a very, very big number. 152, I think. Let's just make sure. Yes. Will give us minus, right, negative times positive, 152 over 2. Now, these fractions will simplify, and that will give us the general form equation. 24 over 8 becomes 3x plus 8y minus 152 over 2, which will be 76. So minus 76. It took us a while to get here, but there's our general form equation. Okay? Okay, so the line passes through the points negative 5, negative 5, 19, negative 3. Determine the equation of the line in slope point form. So again, remember, slope point form, the name of the equation tells you what you need in order to write the equation. You need to have the slope, and you need to know one point on the line. Well, I mean, they've been generous. They've given us 2 points, but they haven't given us the slope. So, when placed in this situation where you know 2 points, but you have no slope, you need to use the slope formula. Okay? So we have to find the slope first. That's our first step. So find the slope. And so we do that using our slope formula. M equals y2 minus y1 over x2 minus x1 gives us m equals y2 minus y1, negative 3 minus negative 5, so plus 5, and x2 minus x1, which is 19, again, minus negative 5 or plus 5. That gives us a slope of positive 2, and 19 and 5 is 24, or more simply, 1 over 12. Okay? So our slope is 1 over 12. Now, all we have to do is take our slope, take either one of our 2 points, and plug them into the slope point formula. Okay? So remember, our slope point formula is y2 minus y1 equals slope times x2 minus x1. We plug in our slope here. We plug in our x and y coordinates for y1 and x1. And I'm going to use this point here. So y minus, since we're subtracting negative 3 here, we write it as plus 3, right? Subtracting a negative is more simply written as addition. Our slope is 1 over 12 times x minus our x coordinate, which in this case is 19. And we're done. That was a lot easier than the first one. Now, this is what I was getting at when I said earlier that you can come up with different looking slope point form equations that describe the same line, depending on which point you choose. Okay? So this one says state two different equations in slope point form that represent the graph of the relation shown. So if we choose different points on this, we will get different looking equations. Now this one is nasty because they haven't given us anything. All they've given us is this line. So we're going to have to figure out the slope, and we're going to have to find a couple of points for our two different equations. Okay, so this one will take a little bit longer. So first of all, let's find a couple of points, and remember, choose points that are right on an intersection of grid lines. That will give you the best chances of getting the right answer because you don't have to estimate, right? So this one crosses through 2 and 1, so it has coordinates, an x coordinate of 1 and a y coordinate of 2. Okay? Similarly, this one down here looks pretty good. It has x coordinate of -4, y coordinate of -1. So we've got our 2 points. Okay? So now we're kind of right where we were in the last question, right? Where we have 2 points, but our first step is we need to find the slope. So find the slope, find m. Okay? So we'll do that. We use these 2 points. So our slope becomes m equals y minus y1, 2 minus -1, or 2 plus 1. X minus x1 on the bottom is 1 plus 4. And that gives us a slope of 3 over 5. Good. Okay? The rest is pretty easy. Okay, so for equation 1, we're going to use this point, -4 and -1. For our equation 2, because they've asked us for 2 different equations, we're going to use our other point, 1 and 2. Okay? So then for slope point form, it becomes y minus our y value here. So minus -1 would be plus 1 equals the slope, 3 over 5, times x minus -4, so plus 4. There's one slope point form for this line. Okay? Now, if we use a different point, we'll get a different looking equation. This one will be y minus 2 equals same slope, 3 over 5, x minus 1. There's our x coordinate. So you can see 2 very different looking equations describing the same line. Let's just put this down a bit so you can actually see it a little better. So this one says the graph of a linear relation has a slope of 16.5. Oh good, they've given us the slope. And an x-intercept of 121, which you might say, that's not enough information. But remember, for all x-intercepts. Remember, that's where a line crosses the x-axis. We know that the y-coordinate is 0. Okay, so remember, all points on that horizontal or x-axis have a y-coordinate of 0. Similarly, all points on the y-axis will have an x-coordinate of 0. So when they give us the intercept, they also are giving us the corresponding, or the opposite, I guess, coordinate. Okay? So for x-intercept, y is 0. For y-intercept, x is 0. So there's our point. We have the point, we have the slope. Now, if all they had asked us to do was write the slope point form, we'd be almost done. Unfortunately, they're jerks, and that's not what they've asked us for. They've asked us for the y-intercept. Okay? So what we're going to need to do is, because of the information we've been given, well, there's a number of different ways we can do this. Probably the easiest is to take our slope-intercept form, y equals mx plus b. And remember, if we have the slope and we know a point, remember that's x and y coordinates. If we have all of these values, then we can find our value of b pretty easily, right? We just need to plug all of our known values in. So we know that y in this case is 0. We know that m, the slope, is 16.5. We know that the value of x is 121. The value of b is our unknown, but we can figure it out because we're smart. Okay? Remember, if you have numbers for all your values and only one variable, you just have to isolate to find its value. Okay? So we've got 0 on this side. We simplify here, 16.5 times 121. I'm not even going to try it. So 16.5 times 121. Calculators are so nice. Gives us 1,996.5. So 0 equals 1,996.5 plus b. The rest is easy, right? We just want to isolate b. So we subtract 1,996.5 from both sides. On the right, it will cancel, leaving us with negative 1,996.5 equals b. Aren't you glad you don't have to graph that? Okay? It doesn't cross the y-axis until way down at almost negative 2,000. Okay, word problems, always a little more challenging, okay, just because of the whole comprehension thing. So, while planning a trip to Europe, Brian and Donna exchanged some Canadian dollars for euros. Brian bought 300 euros for 430, Donna bought 450 euros for 640 from a merchant who uses a linear equation to calculate the rate. Let x represent euros and y represent dollars. Okay? So x equals euros, y equals Canadian dollars. Okay? Determine the slope of the graph of the relation. Well, you know, your first response to this might be, I don't know how to do that. Well, remember, we've got x and y values. In the first case, you have 300 euros, our x value, and $430, our y. So that gives you an ordered pair. 300 for the x, 430 for the y. And also, we have another point here with euros and dollars. 450 for the euros, 640 for the dollars. So we do have 2 points. Okay, this is where the whole word problem difficulty comes in. Okay, you've got to kind of translate first. So we've got our 2 points, we feed them into our slope formula, and that gives us slope equals y minus y1, 640 minus 430, over x minus x1, 450 minus 300. And that gives us, what is that, 210 on top, right? 640 minus 430. And on the bottom, 150. Okay? Let's see if that will be a nice number or an ugly one. It's not bad. So our slope equals 1.4. Okay? Yay, we have our slope. Continuing along, what does the slope represent in this scenario? Remember, in order to figure that out, you have to look at the units. Okay? So our units here are on top, we have euros, on the bottom, dollars. So what they're telling us is 1.4 euros for every dollar. They're actually telling us what the exchange rate is. Okay? It costs $1.4 for every euro you're going to buy. Okay? So I'm so silly. The top should be dollars, the bottom should be euros, right? Because it's delta y over delta x. That makes more sense. It costs us $1.4 for every 1 euro that we buy. Okay? So that's the exchange rate. So what does the slope represent? It represents our exchange rate. Okay? Write a currency exchange equation in slope point form. Well, we have everything we need, right? For slope point form, we simply need the slope and any one point on the line. So, our slope point form for this one is, just keep our slope here, is, remember, here's our slope point form of the equation. So, I'm going to use the first point, so it becomes y minus 430, my y coordinate, equals the slope, 1.4 times x minus my x coordinate, which in this case is 300. That wasn't so bad. Graph the relation represented by the currency exchange equation. So I'm just going to keep my points here. There we go. Okay, so we have an x, we have a y. Because these are positive numbers, right, you can't have negative currency, right? You can't have negative amounts of money. So what I'm going to do is, rather than having an x and a y that has an origin in the center, I'm going to graph this so that my y is here, my x is here. So like a graph that you might make in a science class. Whoa, those aren't very good. Anyways, so my x is euros, my y is Canadian dollars, and for, let's start. We'll start at 0 and we'll go up by, we may as well go up by 50s, okay? So we'll start at 0, and in both cases we'll go up by 50, so that means we've got 100, 200, 300, 400, 500, 600, 700, That should be good enough. Yeah. We'll put one more in. 800. And for the euros across the bottom, we'll do the same thing. 100, 200, 300, 400, 500, 600, 700. Okay? Plot our points. 300 and 430 is our first point. So that gives us 300 and 430 would be about here. And then 450 and 640, so 450, 640 would be about here. Get your ruler, join the points. Now, I'll try to be somewhat accurate here. Okay, there's our line. Okay? So there's our graph of the equation y minus 430 equals 1.4 times x minus 300. The merchant charges a service fee for each exchange. What characteristic of the graph represents the service fee? So this is where you have to take a look at your graph, okay? And the service fee would be right here. Okay? The service fee is what you would pay if you exchanged for 0 euros. In other words, this is added on. So the service fee here looks like it's probably somewhere around $55 or $60, okay? Because it's just slightly above 50. Again, remember, I don't know how accurately I drew this line or plotted these points. We will find out, okay? So it's somewhere around 55. So what is the service fee? So what characteristic represents the service fee? Y-intercept. And what is the service fee? Somewhere around 55 to $60. Okay? Now, I want to find out a much more accurate service fee. So what I'm going to do is I'm going to take my slope-intercept form, y equals mx plus b, because I know that will give me the exact y-intercept. And just as we did in the last question, I'm going to plug my slope and the value of 2 points into this and solve for b. Okay? So I know that my value for the y is 430. I know that my value of the slope is 1.4. I know that my value in this case for x is 300 plus b, and then I just simplify, okay? So 430 equals 1.4 times 300 is, I think it's 420. Oh my goodness, if it is, I didn't do a very good job graphing. Okay, so 1.4 times 300 is 420. Plus b. Then we isolate b, we subtract 420 from both sides. I hope you can still see this. Oh good, you can. So minus 420, that gives us a value of 10 for our y-intercept. Okay? So, as I said, I did a pretty crappy job of graphing this. Okay? So it should have crossed the y-axis further down at around 10. Okay? So the service fee is $10. So we'll erase this, pretend it never happened. $10. And there we go. We're done. We've done all the practice questions. I hope this was some help to you. I'll try and do this again for 7.4. And good luck with 7.3.